Now it's time for us to do the setup and configuration of Spark. But before that, let's talk about the Spark code base. As Spark is also a program or an application or a software, it must also have been written with a programming language. And that programming language is Scala. So Spark is essentially written in Scala, and Scala is a JVM based programming language. So Scala runs on Java virtual machine. There are other JVM based programming languages also like Kotlin, Clojure, Java, etc. If you're not from a programming background, then you might not have come across this terminology called JVM based programming language. So what is meant by JVM based? First of all, I hope you have gone through the Python Essentials course, which is a prerequisite of this particular course. Now I have seen in Python that Python can be both compiled and interpreted language. So if it is a compiled language, what happens is that it goes to the Python virtual machine and the programming language gets converted to machine language. JVM is similar to that, but instead of Python virtual machine, it's a Java virtual machine. What it does is that it takes compiled code as input and execute them using the server resources. So JVM sits here, and let's say we have this code which is not yet compiled. We write it either using Java or Scala or maybe Kotlin, any of the JVM based programming language. Then what we do is that we compile the code. When you compile the code is taken by the compiler and it creates something called a bytecode or executable code. So the high level programming language gets compiled into an assembly based programming language. The reason it is done because JVM understands the assembly based programming language rather than the high level code that we write. So after the compiler creates the bytecode or the executable code, the executable code is sent to Java virtual machine or JVM, and then JVM converts it to machine language and executes the code using operating system and hardware. So that's what JVM based programming language is. So if you write a code, you have to compile the code, and the code compilation will create a bytecode or an executable code out of the high level language that we use, which is passed to the JVM, and then JVM uses machine language to interact with the operating system and to execute the code. So that's what JVM is. And all the programming languages which needs compilation to get converted to bytecode so that they can be sent to JVM, those are called JVM based programming language. A little bit more on the JVM. So JVM runs as a process, meaning that JVM runs as a daemon. If you want to execute a JVM based programming language, you have to make sure that the JVM process is up and running. And you already know what process is. So JVM also is a program. Essentially what it does, it takes the executable bytecode and converts it to machine language. And then it executes the code using operating system and the resources that are available. And the two important components that we have to know for JVM is the heap memory and the stack memory. Because heap memory and stack memory are the memory section which are used by Spark also. And let's say if you are running multiple programs, all those programs would be running as thread on top of the JVM. So a single JVM can execute multiple JVM based programs. So all these programs are essentially the bytecode that I talked about. And all these threads would use the heap memory and stack memory which has been allocated or assigned to the JVM. A single server can have one or more JVMs also, but in most of the cases, a single server typically contains one JVM only. And the executable programs run as threads on JVM, and all of them share the same heap and stack memory. But each executable or each thread would have its own stack memory. What is this heap memory and stack memory? Heap memory is used to store variables, objects, etc. I think you already know what variables are and what objects are. The concept is same as that of Python. In Python also use variables and objects. Essentially in Python, all the variables are actually objects. So heap memory are used to store these variables or objects. The reason I have mentioned variables and objects because in Java, we have variables that are separate from objects. Then you have stack memory, and stack memory is used by methods or functions to store the local variables within the function or the method, and it can also refer objects and variables which are there in the heap memory. So here we have three threads, let's say thread 1, thread 2, thread 3. All three would have their own stack memory in the JVM process. Now imagine that I am running multiple Spark applications or multiple Spark codes in the same machine. All those different Spark codes or Spark applications rather would run as threads on the same JVM. If you have only one worker node, then there will be only one executor JVM, and all the Spark codes or all the application or user code that the driver sends to that worker node would be executed as threads. So let's say there are 4 user codes, then there would be 4 threads running which will access the same JVM process and inherently the same heap memory and stack memory. However, all these different application codes or user codes would have their own stack memory because they are running as threads inside of the JVM. So that is a very high level introduction and overview of what JVM based programming model is and how programs or applications run on JVM. When you use Spark, typically what would happen is that each worker node would contain one executed JVM, and if you submit multiple application codes, all of them would run as individual threads in the same JVM, and they would access the same heap memory and stack memory. But of course, individual applications will have their own memory in the stack or own stack memory for those individual threads. I hope you have understood how this JVM, the heap memory, stack memory, etc. falls in the Spark ecosystem also, or rather Spark executable ecosystem, because Spark is written in Scala, which is a JVM based programming language. You have to make sure that wherever you want to run Spark, you have to have JVM installed. So if you have, let's say, 10 worker nodes, all of them should have JVM running or executed JVM running, and the primary node would have driver JVM running. So driver is a separate JVM process and executors would be a separate JVM process. And when we submit the code, the driver code would be running using one of the JVMs, and the application code or user code that are started by the application master, which is driver code, those would run using JVMs in the other worker nodes, and those are called executor JVMs. As you see, we can submit multiple Spark code or multiple Spark applications to the same JVM. So let's say we have a cluster of 1 primary node and 4 compute nodes. Then we'll have JVM running in all the 4 compute nodes. And whenever we submit one code, one driver would be started in one of the worker nodes, and the application codes or the user code would run in other worker nodes on the JVMs that are running in those worker nodes. If we submit one more Java application or one more Java code, then that code would do the same. It would open its own driver process and then its own executor or worker process. And those would run using the JVMs which are there in the worker nodes. Now let's go through the installation steps for Spark. These installation steps are not needed if you are using EMR or Dataproc, but as we'll be learning in using our local machine, that's why let us go ahead and do the installation in our local machine or maybe in one of the EC2 instances. I'll show you using the EC2 instance because I have already installed Java or JVM in my local machine. You have seen that Spark is written in Scala, which is a JVM based programming language. So what we have to do is that we'll have to install JVM because we need to make sure that the JVM is running, and for JVM to run we need Java also. And then if you're running code in Scala, let's say, then we'll have to install Scala and then we'll have to install Spark. So these are the 3 requirements. We have to install JVM, we have to install Scala if you are writing code using Scala, and then we'll have to install Spark. If you are writing code using PySpark or Python, then we do not have to install Scala. So first we'll have to install JVM, but JVM does not come as a standalone component. We have other components also which have to be installed along with JVM because we need a Java environment. So that's why we'll have to install something called a Java runtime environment. And Java runtime environment is something which helps to run Java code or JVM based code. Now, instead of installing these individual components, we can install something called JDK or Java Development Kit. which would install JVM and JRE and the other components that we see. Along with it, it will also install Java compiler and Java archiver. We do not need Java compiler or Java archiver because we'll be using Python and PySpark. But if we install JDK, then all these components would be installed automatically. So as per the installation steps, this is what we are going to do. We'll have to download and install JDK. Then we'll have to download and install Scala. If you plan to write the program using Scala, then we'll have to install Scala also. Then we'll have to download and install Spark. Once that is done, we'll have to set up some environment variables and we are good to go. So let us go ahead and install Spark. And I'll be doing the installation using an EC2 instance. I'll show you the installation using an EC2 instance because I have already installed Spark in my local machine. Java, JDK, everything is already installed. Let me show you that. This is my local machine and I already have Java installed here, as you can see. We have Java version 21. We have Java runtime environment also. So everything is installed in my local machine, but let us go ahead and install these components in an EC2 instance. And for Windows, the installation would be a little different because you'll be using GUI or graphical user interface to install Java, to install JDK, to download and install Spark. So if you're using Windows machine or Windows laptop, then please go ahead and Google the steps how to install Spark and Java or JDK in your local machine. So I'll be launching an instance. The name of the instance is 3IAM Spark EC2 instance, and I'll be selecting Amazon Linux 2. And maybe the instance type would be a little bigger, that is t2.large. And I already have a key pair named 3IAM DE volume 2 key pair. I'll be using the same key pair. And I'll be launching the instance in one of the VPCs that I have created, which is 3IAM Spark VPC. And it would be in a public subnet. I do not want to install it in a private subnet. And I'll enable auto assign public IP and I'll select an existing security group. And I'll select the security group that I have created. It is a public security group. And I'll configure the storage to be 15 GB with volume type as GP3. And let us launch the instance. And this is the instance where I'll be installing Spark and running Spark. I'll not terminate this instance because after running in the local machine, I'll also try running the Spark code in this EC2 instance so that you see that the installation is correct and the installation is successful. Okay, so once this EC2 instance is up and running, I will SSH into it and then install Spark. First, I'll have to install JVM, for which I need JRE, for which I need JDK. So essentially, I'll have to install the JDK. Once the JDK installation is done, then I'll have to download Spark from Spark's official website. And then I'll have to set up some environment variables. Once those are done, Spark should be up and running. The instance is up and running now. Let's go ahead and install JDK here first, and after that we'll install Spark. This is the public IP address of the instance, and I have created a key pair and I'll log in using EC2 user as usual. Now here, let's see whether Java is installed or not. So there's no Java installed because it says that bash java command not found, which means that Java is not installed here. So for this, we'll have to install OpenJDK. And if you are using Amazon Linux machine, then we'll have to use Amazon's Corretto distribution to install JDK. The reason that we'll be installing using Corretto because it is managed and maintained by AWS. So that's why I'll be using the Corretto distribution. And this is the command to install Java. And don't worry about it. I have all these commands mentioned in the command sheet. And this is the command sheet. You can see that you can actually download and install Java. These are the steps. Then we'll have to create the Java home path. And then we'll download and install Spark. The version that I'll be using is Spark 3.5.5. So after that, after the Corretto version has been installed, you can see that OpenJDK version 17 has been installed, and it is the long-term support 2025 15th April. This is the OpenJDK runtime environment or the JRE, which is Corretto version 17, and then this is the server VM, which is Corretto. Now after this, we'll have to export or set the environment variable or the system variable called java underscore home. For that, we'll have to find out where Java is running and what is the directory where Java has been installed. Now, as you can see, this is the directory where Java has been installed. If there are multiple versions available of Corretto, then we can select a particular version. We do not need that. We'll be using this particular version only. So this is where Java has been installed, and this is what the Java home should be till the distribution number, which is x86 and 64. You do not have to use /bin/java. There are other commands also to find out where Java is installed. First, we can write this command or execute this command file which Java. It will tell us the symbolic link. So basically, if you type which Java, it gives you an output that the Java binary is in user binary Java. Then I have to get the file, right? So that's why I'll have to use this command file followed by this special variable. And then this is a symlink to or symbolic link to this particular directory. Now, if I use file and then this directory, it gives us that this is the version of Java, which is actually same as this one. So this output and this output are matching. And this is where Java is installed. So I'll have to set the system variable Java underscore home to the directory, this one, removing the bin and Java. So this is what Java home is, and this is where Java has been installed. Now what you have to do is that if you are using Amazon Linux EC2 instance or Mac or any Linux based machine, you'll have to set this environment variable in your profile file. If you are using Windows, you'll have to set this Java home in the system variables. You can again Google how to set system variables in Windows, but here I'll have to edit this file called bash rc. And here I'll have to copy the directory and then I'll have to set the path with Java home followed by the path variable itself. Don't worry about it, just copy and paste these commands from the command sheet. Alright, so we have set up Java, then we'll have to install Spark. And to install Spark, first we'll have to get the link. So for that, you can type in Google download Spark. And the first link that you see, we'll have to choose the Spark release. I'm using 3.5.5. And you can use pre-built for Apache Hadoop 3.3 and later. Then click on this link. It will show you that, or it will ask you that you suggest the following location for your download. And this is the endpoint, or this is the URL. So I'll have to copy this URL, go to the EC2 instance and type this command wget followed by the URL name. And it would install a zip file of Spark. Then you'll have to unzip it. And now there would be a directory named spark 3.5.5-bin-hadoop 3. And this is the Spark version that I'll be using. And like Java home, you'll have to export Spark home also. And the directory should be this directory, which is /home/EC2 user followed by this. Sorry, I'll have to remove this dollar and this is what it is. I'll have to copy this command and paste this command in the bash profile file also. So first we'll have to set Java home, then Spark home, and then we'll have to export the binary directory. I will have to put them in the path variable and then export the path variable. And you do not run the export command here. So after this, we'll have to log out and log in back again. And if I type PySpark now, as you can see, I have logged into a Python command line shell or command line interface of Spark. So as you can see, this is Spark version 3.4.4 and I am able to log into it. I'm getting something called Spark session. I'm getting something called Spark context and then Spark session. We'll talk about it later on, but this is how we install Spark in our machine. All right, installation is done. Now there are a few more configurations that we have to do. We'll have to set these variables spark.eventlog.enabled, spark.eventlog.directory, and Spark history fs log directory. Then you'll have to start the history server using a script which is present in Spark's sbin start history driver.sh shell script. And then I can look at the history server in the local host. If it is in my local machine, then it will be in the local host. If it is on EC2 instance, then we'll have to use the IP address of the EC2 instance or public IP address. And what would happen is that you'll find these variables in the Spark default configuration file. And to do that, you'll have to go to the Spark directory, and here you'll find a directory named conf. So go to conf, and here you'll have this file called spark-defaults.conf.template. I'll have to copy it to spark-defaults.conf, and then I'll have to set up some variables. Now what am I going to do is that I have created a directory called spark hist logs, and I'll use this directory to save all the history logs so that the history server is available. So let me go ahead and set up these variables. I'll have to set this to true. So these are the three variables that I want to change, and I'll have to set all these variables to their corresponding value. Hopefully the syntax is correct. So I'm enabling event log, and then I'm mentioning the event log directory to be /home/ect-user/spark hist logs. This is the directory that I have created. Also, I'm mentioning the same directory as the history log directory, and then I'll have to start the history server using this particular shell script, which is start history server.sh. And now the output is gone to the history server log. Let's see whether history server has been started or not. The question is, what is this history server? History server is nothing but the logs or the UI that we'll use in our troubleshooting, in our performance tuning, etc. Now let's see whether we have history enabled or not. And as you can see, this history server is actually enabled, and the event log directory is mentioned as /home/ect-user/spark hist logs. And it is saying that no completed applications found. Let's look at incomplete applications. There are no incomplete applications also because I am not running Spark at all. This is how we do the configuration of history server, and we do the configuration for local machine or for the EC2 instance. So we have installed Spark in both my local machine and in the EC2 instance. So I have configured the EC2 instance, and let me show you the configuration for my local machine. So this is my Java home, and this is my Spark home. This is where I have downloaded Spark, and as you can see, I'm exporting the Java home/binary, and I'm exporting the Spark home/binary, and then I'm exporting the path. And now I can start the history server in my local machine also. And these are the two locations where my history server is. Let me save it, and now I can start the history server on my local machine also using this particular command or this particular shell script. So history server has started, and I should be able to access the history server using my local host also, and it would be in 18080, and there should be history server available. So as you can see, the output is more or less similar. The event log directory is different, and there are no incomplete applications, and there are no completed applications also. So this is how you can configure and set up Spark, its history server, and you should be able to see the application that is running in Spark also, right? Now let's go ahead and run or start PySpark on my local machine. Now if I type PySpark, it is a running application that has started. So as I have started a Spark application, if I go to the history server and click on show incomplete location or incomplete application, I can see that this is running, which is a PySpark shell. It is also telling me the user, the started time, started date, etc. So this is the first configuration, and the second one is PySpark setup. And this setup has to be done in PyCharm, because what we want to do is that if I run any PySpark code from my PyCharm ID, that should also come in the incomplete application or complete application. So first, let us go ahead and run an application. I'm creating a new project, and it will create an environment, and you already know what virtual environment is. Okay, so I have Spark introduction, and here I have virtual environment. Now let me go ahead and install PySpark, and the command is pip3 install PySpark. Once PySpark is installed, you'll be able to see the library here. I'll go into a little bit more detail about this library later on. All right, the installation is done, and as you can see, PySpark has been installed here, along with something called py4j has also been installed. So these are the new directories: py4j, py4j distinfo, PySpark, and PySpark distinfo. These are the 4 new directories that have been created because I installed PySpark. Let me go ahead and create a new Python file and run it as and name it as Spark test. Okay, this is the code. I'm just creating something called Spark session. We'll talk about it later on, and then I'm printing it. So now if I execute this using right click and then run Spark test, it is showing me some output, and let's look at the history server. And I should not be able to see it in the incomplete application. The incomplete application is the PySpark shell again. Let's go to completed applications, but I can't even see completed applications. Even though I executed this code, it is not showing me, this application is not being shown in the Spark UI. And for that, we'll have to make some changes. We'll have to change some environment variables. And that is this. We'll have to go to run and then edit configurations. I'll have to set up Spark home and then Python path. So in run, we have this edit configurations, and here there is no environment variable as such. So I'll have to add the environment variables. First is Spark home, and this is the location in my local machine. And also I'll have to add Python using the Python underscore path variable. And this Python path variable should be the location of the py4j library, and it should be in the Spark home directory. So this is my Spark home, and inside of it you see there's a folder named Python, and here I have this directory called lib, and here I have this py4j src.zip, and this is the location that I'll have to add in this configuration variable. And I'll be adding Python underscore path equal to the entire Spark home followed by library or lib followed by Python and then library. Let me just increase the size. So this is the entire location, and I'll have to add the zip file. So now let's see whether it works or not. Let me execute this again and look at the history server. So now you can see I have this Spark introduction coming in my UI. So this is the another configuration that you have to do for your PySpark or PyCharm setup rather, so that the application that you run using PyCharm is shown in Spark's UI, especially in the history server. Now let's go a little deeper into PySpark. The question is, what is PySpark? Is it a different programming language altogether, or it is something related to Python? Because I had shown you that we can run Spark using Python also. We can run Spark using Python, Java, Scala, and R. And as you might already know, Python provides libraries and modules which can be installed to work on a particular technology. So PySpark is the library or the Python library for Spark. It is as simple as that. And we install PySpark using pip3 install PySpark command. This is the command to install the PySpark module or PySpark library. Once that is done, then we start using PySpark and start writing PySpark code. As we have done all the setup, I had shown you how to install PySpark in the virtual environment, and we have set up the project, we have set up the folder, we have set up the configuration, environment variable. Everything is done. Now let us go ahead and start writing batch programming. But before that, a question might come, because Spark is written in Scala, which is a JVM based programming language. So Python is not JVM based. Python can be interpreted language, or it can be considered as compiled language also if you do pre-compilation of the Python code. Now how Python code runs in the JVM, how it is possible? For Java and Scala it makes sense because both of them are JVM based programming language, but Python and R are not. So for Python, what happens is that we have this Python code and executable. Typically when we run the Python code, it gets interpreted, and in between we have this library called py4j, and whenever we submit the Python code or the executable, then it goes via the py4j library. And let's say we create any object or variable, the same object or variable would be created in the JVM also, and that would be facilitated by the py4j library. If you create any function or method, it would feel like we are doing the same in JVM. So that's what Py4j library does. It is the bridge between JVM and the Python code. And that's why when you installed PySpark, Py4j was automatically installed. Without Py4j, we cannot run our Python code or our PySpark code in Spark's JVM. Right. So this is a very important library. So you might think that there is a translation between Python and Java. Does it add to latency? Earlier, it used to add latency to the execution time because every time it had to convert. But because Python has become very famous and a natural progression from data engineering is actually to machine learning, and almost all the machine learning libraries are first released for Python programming language. So that's why the Spark community has been making the PySpark module more and more performance sensitive, just like Scala. If you run Spark code today using PySpark or Scala, there won't be much difference in the performance. In fact, the performance would be similar. There won't be any difference at all. So that's why you can go ahead and use PySpark library or code using PySpark, and Py4j would internally do the translation without adding to any latency. Whenever we execute any function or method, that would be executed in the JVM. Whenever we create any variable, that variable would be created in JVM's heap memory, and the function would be created in JVM's stack memory. Py4j does the facilitation to bridge the communication gap between Python and JVM. So it gets installed with PySpark automatically. And we have already seen CLI. So if you want to use PySpark CLI, you type PySpark, and for Spark UI to work, you have to set up the history server the way I had shown you. So this concludes the Spark introduction. Let's summarize what we have talked about. So we started with Spark introduction and how Spark fits in the data engineering world or in the data engineering pipeline. Then I gave you a sense of batch and stream processing and how Spark can help in both of them. Spark does processing with batch data and stream data both. Then you went a little deeper into the Spark ecosystem. So the Spark ecosystem is comprised of Spark core, which is nothing but resilient distributed dataset, and then we have data frame on top of it. And there are other libraries like Spark SQL, MLlib, Graphics, etc. Those are built using the data frame API only. Then you talked about hosting platforms like AWS EMR, Google Cloud's Dataproc or Databricks. Databricks is way more than hosting platform, but these are the primary hosting platforms that we get for Spark. We can have or we can make our local machine or our local laptop a hosting platform also. Then I talked about Spark development lifecycle, how we use IDE like PyCharm or Visual Studio and blend that with the cluster and yarn. So after that, I talked about the Spark execution architecture, which superimposes exactly with the yarn execution flow or yarn execution architecture. In case of Spark, the application master is the Spark driver, and the application code is the user code or the transformation logic that we write. Then I gave you a high-level overview of Spark architecture. Then I installed PySpark, and I had shown you the Py4j library that gets installed with PySpark. We'll go deeper into the PySpark library a little bit more in the next section. And then I had shown you the installation and configuration on laptop and on EC2 instance also. I'll not forego the installation in EC2 instance because I'll write a code in my local machine and then I'll run the same code in the EC2 instance also, just to show you the difference or the similarity. So that's all about Spark introduction. Thanks a lot for tuning in. Let's go to the next section.